Good morning to all. Today we are going to see elasticity and plasticity of materials. First, we'll see the properties of matter. A matter is everything which is around you. It is what we can touch, smell, and see. It has both masses and volume, and the energy is calculated in terms of E is equal to mc squared. And it is in five forms: be condensates, solids, liquids, gases, and plasmas. For that, we'll see what is elasticity. Elasticity is the property by which a body resists change in its size or shape when an external force is acting on it and returns to original state after the removal of the deforming force. So, elasticity can be subdivided into perfect, elastic, and plastic. Materials which recover their original shape state after the removal of deforming force are called perfectly elastic materials. Materials which do not recover their original state even after the removal of deforming force are called plastic materials. Here we can see the examples for elastic materials: hair bands, elastic waistband, rubber bands, and balloons. Now we can see the examples of plastic materials: cement, clay, plastic pin, and plastic materials. Now we'll see the physical properties of materials, that is stiffness. Stiffness is the resistance of a material to changes in shape and size. Ductility, the tendency of a material to change its size and shape considerably before breaking. Brittleness is the tendency of a material to break without deforming. Now we'll see what is stress. Stress, when an external force is applied to a body, it gets deformed. Then the forces of reaction is set within the body to restore the body to its original condition. This is called stress. Stress is defined as the restoring force per unit area of the material is called stress. So, stress is equal to force by area, that is F by A. The unit of stress is Newton per meter squared. We can classify the stress into normal stress and shearing stress. So, normal stress can be subdivided into longitudinal stress or volume stress. And longitudinal stress once again subdivided into tensile stress and compressive stress. First, we'll see what is normal stress. When the force is applied perpendicular to the force of the body, then the stress applied is called as normal stress. Here we can see the normal force is perpendicular to the surface which is in contact with the material. So, this is called normal stress. Then we are having shearing stress or tangential stress. When the force is applied along the surface of the body, then the stress applied is tangential stress. This is also called as shearing stress. Shearing stress or tangential stress are here. Then we are having tensile stress. A tensile stress occurs when equal and opposite forces are directed away from each other. In case of compressive stress, which occurs when equal and opposite forces are directed toward each other. Now we'll see what is strain. The change in dimension or shape of a body due to the deforming force results in strain. The strain is measured by the ratio of change in dimension to the original dimension. That is, strain is equal to change in dimension divided by original dimension. For strain, there is no unit actually. We can classify the strain into longitudinal strain, shearing strain, and volume strain like stress. What is longitudinal strain? If the deforming force produces a change in length alone, the strain produced in the body is called longitudinal strain or tensile strain. The change in length per unit length. Then we have elastic limit. The elastic limit is the maximum stress of a body can experience without becoming permanently deformed. Here we can see a stress is applied and the strain is produced. If the stress exceeds the elastic limit, the final length will be longer than the original one. Now we are moving into modulus of elasticity. In case of modulus of elasticity, we are having three modulus of elasticity: Young's modulus, rigidity modulus, and bulk modulus. First we'll see Young's modulus. Young's modulus of elasticity is within the elastic limit, the ratio of linear stress to linear strain is called the Young's modulus of elasticity. Then we are having Young's modulus of elasticity is equal to linear stress divided by linear strain. The unit of Young's modulus is Newton per meter square. Now we'll see how we are calculating Young's modulus of elasticity. In this, a linear force is applied normally to a cross-sectional area of a wire which has the dimension A. We have linear stress, that is F by A, where F is linear force and A is area of cross section. Then L is original length and small l is change in length due to the applied force. So linear strain is equal to small l by capital L, where small l is change in length, capital L is original length. So we can calculate what is Young's modulus, that is a linear stress by linear strain. Applying the value of linear stress and linear strain, we get Y is equal to FL divided by AL, where F is force applied, L is original length, A is area of cross section, and small l is change in length, where the unit of Young's modulus of elasticity is Newton per meter square. Then we are moving into rigidity modulus, where rigidity modulus is a two-dimensional modulus of elasticity. Here, within the elastic limit, the ratio of tangential stress to shearing strain is called a rigidity modulus. That is tangential stress divided by shearing strain. So for that, we are going to calculate what is rigidity modulus. That is, first we have to know what is tangential stress, then shearing strain. First we calculate tangential stress, that is tangential force divided by area of the face, which is shown in figure, that is F by A. Then we are moving into tangential strain, that is small l by capital L. Applying the value of shearing strain and shearing stress, we get a rigidity modulus, that is also N is equal to FL by AL. The unit of tangential shearing modulus is Newton per meter square. Now we are moving into three-dimensional modulus of elasticity, that is bulk modulus of elasticity. Here, within the elastic limit, the ratio of the volume stress to volume strain is called bulk modulus of elasticity, where bulk modulus is equal to volume stress divided by volume strain. Here, when a deforming force acts normally on all the faces of a solid body, not like Young's modulus or shearing modulus, the body undergoes a change in its volume but not in the shape. The body suffers decreases in volume under the action of force. So we are going to calculate what is volume stress and volume strain. By knowing the volume stress and volume strain, apply it in bulk modulus, we get bulk modulus is equal to K is equal to PV divided by V, where P is force applied, capital V is volume strain, and small v is change in volume. The unit of bulk modulus of elasticity is also Newton per meter square. Till now we have seen what is elasticity, plasticity, stress, strain, and modulus of elasticity in all three dimensions. Hope you all understood. Thank you.